Polynomials is a branch of mathematics. In the topic of polynomials, we are going to discuss various types of expressions like variables, constants which come into existence. But before that, let's see the introduction of polynomials. What are polynomials? How do we define them in mathematics? Is what is today's session. When we come to the introduction of polynomials, let me come with the basic properties or the formulae which you have learnt in the lower classes. To recap with the formulae as learnt in the lower classes, one of the most famous formula is a plus b whole square or x plus y whole square. So let's see how we can expand this. We all know that this expansion is a plus b whole square is a square, that is x square plus 2ab, which is this, and b square, which is y square. So x plus y whole square is derived to be x square plus 2xy plus y square. We all know this formula because we have applied in many concepts in the lower classes. Now next comes how this is related to the polynomial. So let's see how this is related to the topic of polynomials as introduction. As we see here, every expansion expressed in the form of variables is a polynomial provided its powers are all whole numbers. Now what is the power of x? For the first term, x square, the power is 2. Next, the power of x is 1 and the power of y is also 1, and next comes the power of y in the third term, which is 2. For this to be a polynomial, the condition is that each of the powers must be whole numbers, as whole numbers of the real number system. So if all the powers belong to the whole number, then that whole expression is called a polynomial. A polynomial with the powers being whole numbers is how we define for a basic definition of polynomial. Let's take one more example. For example, I have x plus y whole cube, and I can expand this. We all know that a plus b whole cube is a cube plus 3a square b plus 3ab square plus y cube. And let's see if this is a polynomial. Now the variables here are identified to be x and y. The variables of the polynomial are the unknown constants which accept any real number. So x and y are just representation of the real numbers in the real number system. So any polynomial can accept all real numbers is how we define for the variables x and y, or only x for the polynomial. So for example, if I have this, I have the power of this to be 3, the power of this 2, the power of this 1, the power of this 1, this 2, and this 3. And I notice that each of the variable has the powers which are whole numbers, and therefore this belonging to w makes the whole of the polynomial, of the whole of the expression given out here, to be a polynomial. Polynomial is defined through the powers of the variables. If the powers of the variables are whole numbers, then the expression is a polynomial. If the powers of the variables are not whole numbers, then the whole expression cannot be defined as a polynomial. Let's see an example which is not a polynomial to understand the concept more better. For example, I have, say, p of x. I denote the polynomial with, say, for example, p of x, which indicates polynomial in variable x belonging to R. Then if I have this to be 3 plus 5 by x plus 4x minus 5x squared, and let's see how each of the powers are out here. Now 3, which is a constant, can be written as 3 times of 1, which indirectly can be written as 3 times of x power 0. So I have my constant with indirectly the power of the variable being 0, because x power 0 or a power 0 is 1, and therefore 3 written as 3 times 1, 3 times 1, which is x power 0. Therefore indirectly I extract from a constant the power of the variable is assumed to be 0 for any constant in the polynomial or in the expression. Next, if I have phi over x, this can be written as phi times of 1 by x, which is x raised to negative 1. So phi over x is phi times x raised to negative 1. Therefore, I assume the power of x in the second term is negative 1. Similarly, I have my third term out here, which is 4x. Therefore, the variable x has the power 1, and therefore I have 1 as the constant derived from the variable of the third term. Similarly, let's go to the fourth term. The fourth term has the power of x clearly seen out here to be 2, and therefore I just drop down 2 out here. Now let's check for each of the constants. I have the constant 0, minus 1, 1 and 2. Yes, this is a whole number, this is a whole number, this is a whole number, but this is not a whole number, because minus 1 does not belong to W, as discussed in the previous sessions. Therefore, since minus 1 does not belong to W, therefore the expression P of x given to be 3 plus 5 over x plus 4x minus 5x squared denoted by px is not a polynomial. It fails to be a polynomial because one of its integral power, one of its power of x does not belong to W, the whole numbers. Therefore, P of x is not a polynomial. Is how I identify the definition of a polynomial from the powers of the variables. In this case, x being the variable. Next, let's see the different types of polynomials. Now that we have defined what a polynomial is, let's classify the different types of polynomials existing in the branch of mathematics. Now, types of polynomials is the session. As we discussed about the definition of a polynomial, let's take, for example, a polynomial of one term. A polynomial can have any number of terms depending on the given problem. So what if it has one term? What if the polynomial has two terms or three terms or four terms or etc. and etc. So let's start with a polynomial which has one term. So let me take, for example, a polynomial P of x equals 4x. Surely this is a polynomial because its power is, the power of the variable is 1, which belongs to whole numbers. Therefore, P of x is a polynomial. Specifically, P of x is a polynomial of one term. There's only one term out here is what we need to notice. Now, in this case, any polynomial which has one term has got its specific name, which is called a monomial. A monomial is a polynomial which consists of only one term. Let's take one more example. How many terms out here? There are two terms. But is this a polynomial? Yes, of course. The power of x is 1. Each of 1 belong to whole number. Therefore, this given expression in the given example problem is a polynomial. But this is not a polynomial of two terms because this can be further simplified. Like 14x minus 2x, which can be further simplified to get 2x. So we need to simplify this further to get the most simplified form, and the most simplified form of the given problem 14x minus 12x is 2x. So this is the actual polynomial which intends to be decided on. Now here, the power of x is 1. It belongs to whole number. It's a polynomial, and it is a polynomial of one term, and therefore this polynomial indirectly given by this is a monomial. So the learning outcome in this example problem is that when a polynomial is decided for a monomial or any other polynomial of more than one term, we try to decide on simplifying the given polynomial to the most simplified form and then decide on the number of terms in the polynomial. The number of terms decide the definition of that particular polynomial. In this example, this being simplified to get 2x, and hence it's a monomial. Monomial is a polynomial which consists of only one term. So here I have the learning outcome which says monomial. It is a polynomial containing only one term, is how we define the monomial, a polynomial with only one term.